Hi ladies and gentlemen, this is another in my series of lessons in geometry. I wanted to point out to you that I am right at the end of Unit 4. Okay, this is the last lesson that I'm going to be recording a lesson for in Unit 4. So next week we're going to be taking the Unit 4 test part 1. You can expect that I will be doing a review of Unit 4 uh, this Thursday, and I will be sending out a review of that Unit 4 before you take it next week. Okay, so you should be getting a review that you could look at. Okay, don't panic about it. You're taking it during, I know, Thanksgiving week, but it's only Monday and Tuesday, so I'll send you a review. Now, don't forget, you should be making quiz corrections. If you're making perfect grades, hallelujah, let's go on. If you're not making a perfect grade, you ought to make a correction to every one of the ones you miss, because you never can tell when those questions are going to show up on the mid-unit or the unit exam. So you want to make certain you understand how to work them, okay? Due dates. Due dates 28 days after a lesson closes, they do go into effect. They close, they lock. You need to make certain you get things done before that time frame. Let's move forward. One of the things we studied back in Unit 1, yes, I said Unit 1, was the segment addition theorem. That's where we said if I take a line segment AC, okay, and I've got another line segment AB here, and B is sitting actually between A and C, I can say that the line segments add together to give you that whole line segment, right? So anytime I've got a part of a line segment that I'm adding together, it's called segment addition, right? If I add the line segments together, I would get, okay, come on, there it is. If I add part of a line segment together, it's going to equal the whole. So the two parts equal the whole, or what they call here the betweenness postulate. It says if A plus B equals B plus C, then A equals AC, then points A, B, and C are collinear. Remember, they're all on the same line, and point B is between points A and C. Right? That's what it means. Did I put these in the wrong place? I did. I'm sorry. Let's get the right point there. Nope. 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 Okay, get out of the way then. Nope. That's the one. C. C goes at the end. B goes right here, like that. And then this one goes right there. Goes from B to C, like that. Okay. What it's saying is if these line segments add together to equal the whole line segment, then the points are collinear and B lies between points A and C. That's the converse of the segment addition postulate, but it's still that same concept, right? It's that betweenness postulate that you can look at there. This is another one where we're taking the postulate and its converse, and we're using that information. Okay? Where does this come into play? It comes into play with triangle inequalities. What? Well, think about it. If these lines represented the sides of a triangle, right? Well, if they represented the sides of a triangle and I could add them together like this, it wouldn't really be a triangle, would it? It would just be a straight line. And that's one of the things that they're trying to tell you here, is if we have A plus B equals C, and C is greater than 0 and A is greater than B, to form the triangles, to form a triangle from three segments, the sum of any two sides has to be greater than its third side. Because if they were the same size, it'd be a straight line. If they weren't equal, they wouldn't meet. They wouldn't reach each other. So let's look at some examples of this. Oops, I missed the other part of this. In that same triangle, the larger angle lays opposite the longer side. So if we're looking at this right here, well, I know that 60 plus 40 is 100, and that means I can figure out angle C over here is 80 degrees. If I know the three angles like that, I know that the longest side is going to be opposite the biggest angle. So I can just draw a line straight across. That's going to be my longest side, AB. Okay? That's going to be the biggest one. I'm going to put it over here on the biggest end. Okay? From the same perspective, the smallest one is going to be CA. Why? Because it is opposite the smallest angle. And so BC is going to be the one that's going to be in the middle. Now this all stems from that line segment addition. Okay? We're still stemming from that point. But we can determine the biggest side in a triangle by knowing the biggest angle in the triangle. Okay? How about the other way around? Can I determine the biggest angle from the biggest side? Yes. If you look at this, 45 is the longest side here. So I can just draw a line across from that, and it's pointing right at angle S. So angle S is going to be my biggest angle. I'll put that on the biggest end down here. Okay? Well, which is my smallest side? 33. That'd be T. T would be the smallest one. It would go over here. And that leaves R going in the middle. R is going to be in between the two of them. Does this help us? Well, sure, if we know one angle and we know the relationship between them here, we can say, well, this one's got to be a little smaller than that, and that one's got to be a little bit smaller than that one. That helps. That will help us in working out some information. You will see questions just like these, okay? Now, let me also point out, if I add 33 and 35, that gives me 68. That's greater than 45, isn't it? If I add 45 and 35, that's 80. That's greater than 33, isn't it? If I add 33 and 45, I get 78. That's greater than 35, isn't it? The triangle inequality theorem tells you that you can add two sides will be greater than the third side. Now the trick I always tell people is add the two smaller ones. If you add the two smaller ones and it's greater than the biggest one, then you know it could be a triangle. Okay? Because after all, it just has to be bigger than the biggest one. And if you're adding the biggest one in what you're doing, it's obviously going to be bigger than the other ones. So you add the two smallest ones. That's the only one you really have to add. Add the two smallest ones to see if they're bigger than the other side. That is the trick. So one of the types of problems that you might see, if I gave you three numbers, 9, 11, and 17. Will those make a triangle? If I had a side of length 9, a side of length 11, and a side of length 17, would those make a triangle? Well, 9 plus 11 is 20. 20 is greater than 17. So yes, that would make a triangle. Okay? How about if I gave you 9, 11, and 21? Well, 9 plus 11 is 20. 20 is not greater than 21. No, that will not make a triangle because 9 plus 11 is not greater than the third side here. Okay? You guys seeing what I'm saying? 9 plus 11 is less than this. So that would not be a triangle. But up here, 9 plus 11 is greater than 17. So yes, this would be a triangle. Okay? That's the type of questions you're going to be looking at. And I want to make certain you guys know how to work those type of questions. Cool. Okay, what we're using is we're using constructions to explore the attributes of geometric figures and formulating tests and testing conjectures about properties and attributes of polygons. That's what we're doing at this point, is we're trying to get those things across to you because these are the types of questions you would face if you were looking at those two topics right there. Okay? Want you guys to keep sending me the fact that you're in geometry when you send me questions. It really helps me find your answers and get them to you a lot quicker. I look forward to talking to you next time. Bye.